an idea here. Jeremy's weight for the past 4 months is shown above. Jeremy makes the statement, I have never weighed 200 pounds. Based on the data above, is this statement true or false?
False.
Okay, why would you say this is false?
Because March and April, we weighed 203 and 204.
Right. So you're making an assumption there, right? You're making an assumption that to go from 199 up to 203, that you got to weigh 200 sometime in between there, right? So you're making an assumption here that weight has to be continuous. And I would also agree pretty much weight has to be continuous. I mean, I guess if we're on like a molecular level, maybe not. But yeah, like if you like, you know, have a toe amputated or something, you might lose all that weight at one time. I don't know, but get a haircut. If we want to get on a technicality, maybe it's not continuous. But in the general sense, we usually care about weight. You didn't go from 199 up to 203 without passing the 200 mark, right? So with the assumption that weight is continuous, he definitely weighed 200 pounds. Probably sometime between February and March, right? He had to have weighed 200 pounds in between these two right here. So that right there is pretty common sense, and you guys all immediately said, yes, of course he weighed 200 pounds, right? That to go from 199 to 203, he had to weigh 200 pounds. That is pretty much what the intermediate value theorem is saying, right? It's going to say it in very mathematical language, but it is pretty much saying to get from this lower value to this higher value, you got to pass this value in between, right? So the intermediate value theorem, this is your like formal mathematical language. If f is a continuous function on the closed interval from a to b, and d is a number between f of a and f of b, then the intermediate value theorem guarantees that there is at least one number c between a and b such that f of c equals d. Now that sounds very confusing just listening to it read out. But let's look at what it would look like on a graph, okay? So we've got, first of all, f must be a continuous function. You might want to underline or highlight that. If f is not a continuous function, the intermediate value theorem does not apply. So there are some things that are not going to be continuous, that very well could jump around, and this does not apply at all for that. Right, if you have a jump in the graph, if you have an asymptote, even if you have a hole in the graph, then the intermediate value theorem would no longer apply for this. So f being continuous is, of course, very important at first. We're looking on the closed interval from a to b. That is on our x-axis. So I'm going to put a right here and b right here. And I'm just going to draw a function of some sort. It really doesn't matter what it looks like. I'm going to do this. This is, and we're going to call this f of x. Okay. So we're concerned with like these two endpoints that we know about, a and b. So if I go sort of up here, right here at this point, my x coordinate is a, I could call my y coordinate f of a. So that means over here on the y-axis, I could label this point f of a. Like that. Another parentheses right there. And I could do something similar with my b. Right here. So this would be the point B, f of B. Alright, so that would mean if I want to label my y-axis right here, this would be f of B. And again, my function could look any number of ways. It just has to be continuous, which this is. So it's telling me that if we're continuous from A to B, and D is a number between f of A and f of B. So I'm going to put a number B between f of A and f of B. I'm going to put D right here. And so I'm going to draw myself a dotted line out here like this. Essentially what this is telling you right here is to get from this point right here up to this other point right here. If you have a continuous function, you've got to cross D, right? And that has to be true. So like I've drawn this line, it crosses D right here. At least once. It might cross a bunch of times, right? My f of x could look a number of ways. It could be like a sort of sine-looking function, go back and forth across D several times. But you can't get from right here to over here without crossing D. That's your 200 pounds. So like if this is 199 and this is 203, his weight, if you're graphing his weight, it is not going from right here at 199 to over here at 203 without crossing that 200 pounds, right? And the C value that they put right here in that definition, colors, that C value, this point right here, that would be your C. It's just telling you there's got to be at least one C point in there. It could be somewhere in between, right? So the general idea is really basic. It's like something that we kind of understand intuitively when we're talking about different things. So let's look at what like types of problems we might get for something like this. Number 1 says explain why the function f of x equals e to the 2x minus 5 must have at least one 0 on the interval from -1 to 2. Okay, remind me, what is a 0? Okay, it is x-intercept where it crosses the x-axis. Okay, add an x-intercept, y equals 0 at that point, right? Okay, so I've got this function e to the 2x minus 5. This would not be a calculator active problem where you could graph this or anything. And I want to know between -1 and 2, I want to know if I cross the x-axis. If you remember a lot of trigs, a lot of exponential stuff, you could plug a 0 in here and solve for that value for this particular function. That's not really the direction I want us to go because I want us to use intermediate value theorem, right? So, first of all, I must know, is f continuous? E to the 2x minus 5. What do exponentials look like? They just go up. They're continuous everywhere, right? So, f is continuous because it is, I've just committed a terrible sin. And I am repenting of my evil doing. Do not ever, on your paper, write the word it, because the number of points that I took away from children for writing the word it this summer when I was grading AP tests could make someone cry. Don't write the word it. It is a cuss word. In this room, we're not going to say it, or we're at least not going to write it on our paper for any type of free response question. So, f is continuous. When I say it, I need to say what it is. I know it sounds like almost like bad grammar to say F again right there. It's not like the most fluid sounding, but just don't risk putting the word it there, because in this case, I think you could say, yes, it definitely means F. But sometimes there are several things it could mean, and it will not be good if you use it. So just say F is continuous because F is exponential.
What's the difference between putting F and F?
Not much. You can call it F or F of X. F of X is perfectly fine. F is a little bit shorter if you want to write it that way. So if you just use the first letter, we assume you mean F of X, or sometimes it's F of T. So you don't have to put the of X with it, but if you do, it's perfectly fine for that. So F is continuous because F is exponential. So since it is continuous, the intermediate value theorem is going to apply. So what I need to know is I need to know what like my endpoints I'm working with are, right? So I'm going to do F of -1. I'm going to plug in -1. Okay. That is going to give me e to the 2 times -1 minus 5. Now, this is a little tricky because this is not calculator active, and I can't type that into the calculator to figure out what it is. I also don't know why that just moved that for no reason. Okay, so I can't type this into the calculator to know what it is. But I do know if I have a negative exponent, I can make it a fraction, 1 over e squared minus 5. Is that going to give me a positive or a negative number? It's going to be negative because 1 over e squared is going to be a really small number, right? E is like 2.718. When we square it, 1 divided by that, it's going to give me a small decimal. Definitely something smaller than 5. This is going to be less than 0. So when I plug in -1, I get a negative number. I don't know exactly what it is, but I know on a graph I'm somewhere down here below the x-axis when I plug in -1. Then I want to plug in 2 to get the other endpoint. So this would give me e to the 2 times 2 minus 5, which is going to be e to the 4th minus 5. Again, I do not know what e to the 4th is without having my calculator available. It is 2.718 something to the 4th power. Are we going to get a positive or a negative number there? Positive. It's positive. So this is greater than 0. So all we really care about is a positive and negative. So over here at 2, I've got a positive number. So if f is continuous, and we said that it is, then to get from here to here, what have I got to cross? I've got to cross 0. I've got to cross the x-axis. I don't know exactly where, but I've got to cross it somewhere, right? This didn't ask me to find the spot. It just asked me to explain why it must happen, right? So we can say, since, we're going to say, I like to do it, well, actually, in this particular case, normally I like to use the actual numbers, but we don't know the actual numbers here, right? So I'm going to say f of -1, which is 1 over e squared minus 5, whatever number that is less than 0, less than f of 2. So 0 is in between these two values right here. This is some negative number, right? This is some negative number right here. This is some positive number. 0 falls between it, right? So since that's the case, by the intermediate value theorem, and I like to just restate, explain why the function must have at least 1 0 on the interval from -1 to 2. I would say f must have at least 1, 0 on the interval -1 to 2. There are other ways you can word it. I just like to use the question to not have to worry about it. You're basically just stating what it said, right? Okay. These are sort of like proof. These show up on the free response questions a lot. One may argue they're not really that much of a calculus problem because we didn't do any limits or anything there. So, in fact, I am questioning why this is even considered a calculus problem, but it this shows up on the free response part quite a bit. So, it's in the curriculum, but I don't know if anything about that really has to be calculus necessarily. I think you could probably apply it earlier. But this is the general idea. All right, so one thing you must begin by saying that f is continuous. If you don't state it's continuous, you won't get full credit on that. Then you got to show the endpoints, say this is in between, and then make your conclusion. Yeah.
You need to include that because it's exponential.
It's probably good, but I think if you just said f is continuous, you'd be okay. For that. Okay, so for example 2, and there's a decent chance this will be the last one we get in today, and that'll be okay. On the interval from -1 to 4, prove that the function f shown below, I should say prove that for the function f shown below. There is some c such that f of c equals -3. Justify your answer. Okay. The first thing we always have to tell is whether or not the function is continuous. If it's not continuous, we are out of luck and cannot answer this question. So I'm betting that it's probably continuous. Now, this function does have a discontinuity. Where is it at? At 5, right? Is 5 on the interval? It is not on the interval. So I would begin, because continuity is always what you need to start with, I would begin by saying something like this. F is discontinuous at x equals 5, but since the interval -1 to 4 does not contain 5, f is continuous on that interval.
Can you just say it's continuous on that interval? Do you have to put that before?
It really just depends on how they've set the points on that, or whether they would consider it. A lot of times what you'll see on this, if it's on free response, is maybe like part B of the question was asking you to prove it was continuous, and then part C is asking you an intermediate value theorem problem. So I don't know that you'll see just this too often there in a free response question. It usually would have already been done earlier. Like you'd find your discontinuities earlier in another part is what usually happens for those problems. But since this is not like a full free response question, we need to put this. When in doubt, even if you don't know why, definitely say it's continuous, because you can't use intermediate value theorem unless it's continuous. And just don't put a reason and hope it's good enough unless you're pretty confident with that reason. All right, so This time our interval is from -1 to 4. This time we're not asked about a 0. What is our like y value that we want to know if we cross? -3. So like if we think of just doing a rough sketch for our own, thinking here, we're going from -1 to 1, 2, 3, 4, and then we're wanting to show that we got to cross that line at -3. So in this case, you need to find your points for your endpoints. So f of -1 is going to be -1 squared minus 9 divided by -1 minus 5. And that is going to give you 1 minus 9 over -6, which is -8 over -6. A negative over negative is a positive. I am going to reduce this, though you don't have to. It's 4/3 or 1.3 repeating. So our point over here for -1, it's like, maybe here. And then I need to do the same thing for the other endpoint. I'm just plugging in 4. So I've got 4 squared minus 9 over 4 minus 5. So that's going to give me 16 minus 9 over -1. And that is going to be 7 over -1, which will give me -7. Okay, so 4 -7 is going to be down here somewhere, right? To get from here to here, do I have to cross that dotted line? Yes, I do. You are proving that this is the case. The way that we want to do that, we've already said it's continuous. We've shown what the endpoints are. We're going to say since. Now, here, which one's lowest? F of 4 or F of -1? F of 4. I like to do this. I do F of 4, which equals -7. That's kind of optional since you've already shown that it equals -7. That is less than -3, because -3 is that value that we are concerned about crossing, right? Which is less than 4/3, which is what we got for F of -1. Now, where I like to write it this way, where I've got both of these things right here and both of these things right here. As long as you've shown your work and labeled everything well up here, you could leave this off. You could write it either -7 less than -3 less than 4/3. You could write it that way. Or you could write it F of 4 less than -3 less than F of -1. You could do either one of those things as long as your work is shown well up here and labeled. I like to just go ahead and do this to really show my point there. But you have some options on that. So since this is true, since -3 is between our two endpoints, we'll say by the intermediate value theorem, and then I just restate, there is some C such that F of C, I really should say there is some C on -1 to 4 such that F of C equals -3. There is some C on the interval -1 to 4 such that F of C equals -3. Okay, that's all we're going to do today. I'm not going to give you the assignment part that we were going to do with this. We will probably just kind of shorten that. I don't know if we'll do the whole assignment. We'll just do a few more problems like you might see. Your assignment over the weekend, if you haven't already done it, is that progress check. It's just part A, multiple choice, okay? Because we will spend Monday and Tuesday looking at the rest of the progress check and reviewing for our test. Other than we didn't quite finish these notes, we are done with Unit 1. We will look at a couple more problems with this so that you've got that, so that you understand that. But other than